So what we're talking today is about NFV and how we can get from physical boxes to virtual and open infrastructures. So I have a full agenda for today, so hopefully I'll make it very exciting for you. I'm going to cover lots of ground here. Where we are today, a year later, actually it marks the 1 year anniversary, which is pretty awesome, and you know, we're about the same age as the OpenDaylight. I'll be talking about the use cases and the proof of concepts, the Open NFV, and how open source can be instrumental in NFV. A little bit about NFV and SDN and how these things can be synergetic. What we've been doing in Orange with respect to NFV, and they sharing some thoughts about the future of something, and I will get to that later today. So just setting the stage here and clarifying the things about NFV, there's one single definition that is about moving what's today happening in dedicated hardware boxes into software. That's one single definition, so there shouldn't be any confusion. And this is by leveraging commoditized servers and IT virtualization. So we also mentioned the word high volume. Hopefully it won't be that many servers that we need to do that. So as we can pack a number of VMs within a server, you know, that would be the ultimate goal. And about the group that we formed about like a year and a half ago, this is about producing specifications and an architecture framework. It's not about standardizing any of that, at least for now. Okay, so this is maybe a picture that most people are familiar with. This is on what you see here is the classical network model today, which you have a bunch of hardware appliances in your network that essentially, you know, do whatever you want them to do in your network. And these are like, they have a specific role. So there's one physical box per role. They require physical install, so you have to send someone out and deploy those boxes in your network. It's very static. It's very, very hard to move and to scale up and scale out as well. So the vision behind NFV is essentially how, again, you can move all of that into software. So you can see all these things and how you can make things more scalable and also be able to remotely operate your network. So these are moving to a very dynamic, essentially, environment and very easy, again, to scale. Let me give a little bit of history on how we got here today, actually. And NFV has its genesis, its roots in SDN, in particular, in the Open Networking Summit. During a cocktail reception, I was introduced by Dan Pitts to Don Clark of British Telecom. So I said, hey, we should probably get together the carriers and maybe form a working group within ONF to pursue some of our interests that are particular to the service providers and the telcos and the carriers. So we can, you know, see what are the issues that we can start working on with respect to SDN. And that's when we met. The next day we met with Verizon and Deutsche Telekom. So we starting some conversations around this topic. And then there was a subsequent meeting in Paris in June of 2012. That's in 2012, actually, happening. And that's when we coined the term NFV, Network Function Virtualization. And given that Don is British, the S in virtualization has to be S and not Z, of course, in case you're wondering about it. And then we had a subsequent meeting in our office in September up in San Francisco, and that's where we've decided to go with ETSI as the umbrella organization for hosting NFV. And as you know, the rest is history. We published our first white paper back in October of 2012, and last year we did the second white paper. The kind of applications, it's all over the place. So it sort of like spans across your mobile and fixed network. So any device today that stands in the network as a physical box has the opportunity to become virtualized. So I'm not going to go through the list here. This is something that you've seen. You're going to get, I guess, copies of the slides. So you can check this later. So about the group, just a few things. It's a group that it has a global members from all over the world and operators. Most of the major operators of the world are members of that group. We have grown to more than 170 companies, actually, and more than 28 carriers, including also the cable industry. Okay, it's open membership, so you don't have to be a member of Etsy. You can participate as a participant. You just need to sign an agreement. It's very easy. Deliverables are requirements and specifications, the architectural framework I talked about, and also POCs, and forming some liaisons. In terms of structure, it's pretty straightforward. I call this the UN of the telcos and networking. Essentially, we have members from all over the world, including on the leadership positions. So I'm not going to go over that. The important thing here to mention is there's a network operators council, so where all of the operators are represented. And the role is essentially to provide some advice to the rest of the committee, the rest of the members, and the technical committee that actually steers the work happening in NFV. The working groups are divided into groups. We have the architectural groups, so we have the infrastructure, the management, orchestration, and the software group. They are related to dealing with the functional requirements for NFV. And there's also have the transversal groups, which is the performance, reliability, and the security, and have related to non-functional requirements. The last two groups, reliability and security, actually are expert groups. All right, so what are the objectives? Well, the objective was to provide, again, a common requirements and architectural framework. So in fact, last year, we published the 4 specification documents, was also ratified and published on our public portal in October of 2013. So these 4 documents are the architectural framework, the use cases, the requirements, and terminology. And you can check this out at the website. However, we're not done yet. There are a few more things to actually touch upon. And the one thing I want to highlight essentially is how you can integrate multiple virtual appliances, those devices, those appliances that we build today in software, how you can integrate these into your existing infrastructure. That's one issue. And the other issue, how you can interoperate with other vendors that are coming up with different virtualized appliances, and they want to put this into your network. Managing and orchestrating also many virtual appliances is going to be a challenge, and that's the part of the management orchestration framework. Achieving scale through automation, this is very, very, very important to us, and we identified this early on in our white paper, and we said in order for NFV to succeed, you have to reach the scale that you need, and you can only do that through automation. And the keyword behind automation, of course, is programmability, right? It's software. Okay. Again, a few more things. We have to look at whether we need any templates or patterns or configuration schemes for essentially launching those VNFs, virtual network functions. We are also developing and exhibiting a proof of concept. This is like an ongoing work right now. I think we've announced 4 official POCs so far, and there are more to come. We're also performing a gap analysis to see how we can map certain tasks today into relevant external bodies and standardization efforts that are going on right now. And of course, OpenDaylight is one of them. Again, this is like a map of the external relationships that we're trying to pursue at this point. There's no reason to go over that. It's like a bunch of different organizations. The key thing here is to try to avoid any fragmentation. So we don't want to see our work being fragmented and all over the place, and each of these SDOs getting a piece of it, and then getting into some sort of a disagreement on what should be done. We definitely need to avoid that happening. So this is very, very important. In terms of the use cases, we have split these into, again, 2 groups. One is the architectural use cases, the other one is the service-oriented use cases. So here, like I mentioned a few of them, network functions virtualization infrastructure as a service, that seems the one that really stands out. And here I show an example of these NFVI as a service, where you actually have an administrative authority and a service provider essentially using the facilities of another service provider to provide an end-to-end service. So this is something to make a note of. And there are other also use cases, virtual network function as a service, virtual network platform as a service to try to map, the different the terms out there when it comes to the cloud services. This is, again, another example of how you can achieve multi-tenancy in an NFV environment, in an NFV network. Again, different platforms at the bottom, as you see, with respect to the service offerings, network service offerings. Okay, and the second set of use cases is the service-oriented use case. And these, again, they span across the board different use cases from the mobile core network and IMS, all the way down to the virtualizing the mobile base stations and cloud run, to the home environment, your CP, your home gateway, essentially, to CDNs, and to the fixed access network, and that may also include any optical portions of it. There's a document on requirements. I'm not going to go through that list here. It essentially focuses on the difference when it comes to essentially implementing NFV in your network. Okay, what are the different type of requirements that you need today in order to bring in NFV into your network, and how you can migrate to this new paradigm, to this new environment. So this is the high-level view of the NFV framework. This has been actually something that we have published. You see the hardware resource on the bottom, have the visualization layer. This is something that shouldn't come as a surprise to most of you. Have the VNFs running on top, and vertically across we have the network, the NFV management orchestration that essentially tries to manage all these different pieces of this framework. The one thing I added to this picture is that you have to have applications running on top of your infrastructure, and hopefully you'll be able to get these applications from a cloud or a network app store, the same way that there's a market store today if you're looking at Android or your Apple app store, where you can actually go and download an application that you think fits your profile and needs. So the management orchestration part of it is a very, very significant component that essentially provides a lifecycle support and management of all your resources, whether these are physical resources or whether these are like virtual resources. And because there are like a number of issues that are presented, and certain challenges are presented when you're trying to introduce network, trying to introduce visualized network functions into the network. So hopefully the management orchestration, we'll call this MNO, will try to address these issues in your network. And also, it has to closely work with your OSSNBS, the operations service support system, and your business service support system. Okay, this is a more detailed view of the reference architecture. You see the OSSNBS on top of it, and also we show the different interfaces across the different components in your infrastructure. If you read our documents, there's like a detailed description of what these interfaces are and what these boxes are. You see there's an EMS, an element management system for each VNF. My vision is maybe we can see one day a common EMS for the different VNFs, so we don't have individualized EMS systems for every function in the network. Another thing that presents a lot of interest is the network functions following graph. That provides logical description of interconnecting the various network functions in your infrastructure. Because now that you're virtualizing the functions, somehow you need to interconnect these, right? You need to couple these. Some people call this service chaining. This is a term I'm not really, I don't particularly like myself because it has the chain thing in it, but you can think it's like a service or a functions concatenation or coupling or linking. You can have nested forwarding graphs in your infrastructure if you want, so that's a possibility. And perhaps that also raises the need for new virtualization monitoring tools in your network. So hopefully if you can click on the nodes, that will be substituting essentially the ping command that we use today. This, again, another view of NFV and the different layers, starting from the hardware resource all the way up to the software instances, which represent the VNFs. And the end-to-end, again, picture. POCs, these are like, we call them proof of concept, but essentially these are like proofs of capability, just to demonstrate that this is something that we can actually do today in our network as a pilot phase. And it's a very lightweight process. If you want to contribute, it's very easy. If you're a vendor, you just need another vendor and operator. If you're an operator, you just need two vendors to come together and put together a POC and submit that to ETSI and to get approved. So it's a very, very lightweight process, as I mentioned. Okay, OSSNBS, as I mentioned, this is very, very critical to us because we do rely a lot as telcos, as carriers on that. The key thing here is that NFV perhaps requires new thing about how we can actually use OSSNBS in our system, where it has to be completely aligned with this new environment, with this new infrastructure. And we think that the management orchestration part of NFV complements the functionality of OSS. And again, automation is going to be key. This is where we are today. This is like a work in progress. So a lot of things to be done. We're supposed to sunset like a year from now. That's because we operate under industry specifications group guidelines. I'm going to switch to the strategic networking paradigms with respect to open source and SDN. This is something that we have published in our first white paper, and actually I see the same Venn diagram in some of the brochures distributed to you today. And we're like visionary enough to mention open innovation SDN from the get-go. And so I'll be talking about the open innovation first and an open ecosystem that we try to build around NFV. The elements of that open ecosystem is going to be open source and open design and development. So here we're looking at open source software, but also open hardware as well. One thing that really comes to mind is the OCP project. There was a summit last week, so that becomes quite relevant to us. What should be open? That's something we have to determine. What's going to be the interfaces? It's going to be just the functional blocks in the system. It's going to be just software, or what else? Could we have a standards-based open development? That's another question that we have to answer. Decomposition and modularization. NFV is something that essentially enables a complete decomposition. Some people call it disaggregation of your system, and modularization. Modularization leads to simplicity, so we like simplicity. It favors also best of breed, so you can choose a solution that fits best your particular situation. So, and if you want to upgrade to something else, you don't need to change the whole system. You just go and upgrade that particular component, or you switch vendors if you want. Some people call this the IKEA model. Well, hopefully with more screws than those that you get with the IKEA model. And customization, again, it helps a lot to customize your design. However, there are going to be some challenges along the way, and this is how essentially how you can integrate all these different components into your system, right? And that may require standardizing interfaces, for instance, right? If you want to have a plug-and-play type of situation. And also compatibility and consistency, how you make sure that a solution provided by one vendor fits with a solution provided by another vendor for maybe for a different type of function. It has to be carrier grade. This is very, very important to us. When we go to open ecosystem, how you make a solution carrier grade. We're talking here about high availability, disaster recovery, and business continuity, SLAs, and so forth. Security, testing, and interoperability. Very, very important. Certification and licensing, if that's going to be required. And also what's going to be the impact with respect to regulation. Okay, when you go to opening up your systems, what does it mean in terms of regulation? Okay, so this is like food for thought. We do, however, have a wish list for OpenNFV, and that consists that we need to make sure that we build on existing diverse open source initiatives, and Linux and OpenDaylight is of course one of them. We have to make sure that we maintain an open environment, so we allow for plug-and-play type of solutions, so that come from different vendors, and so we have to avoid any singularity here. We have to essentially allow for diversity. And it would be nice to have a sandbox of open source tools. So if I want to get something, I should be able to go and download that application or have someone integrate that application into my infrastructure. And so I can enable also some APIs on top of that I can open up to my customers or to other providers. And essentially, what we're looking is creating a dynamic and inclusive and very synergetic environment to foster that open source NFV and accelerate implementation. So how you coalesce all the community around that, given that we don't have software engineers, we're not like Facebook or Google where you can actually employ people to do that. That's also remains to be seen. I have to rely on the community like you today here to help us make this happen. Okay, so here's how we map to different open source communities. You can see we're like all over the board here with OpenDaylight, ONF, OpenStack, OCP, and so forth. I don't want to make sure that we don't miss anybody here. OpenDaylight, we think provides a complete and integrated platform. So this is something, of course, to take into serious consideration. And the other thing on the Venn diagram was the SDN. So NFV and SDN in terms of end user perspective, we think that SDN can play a very, very key role in the orchestration of the infrastructure. A bunch of things here that we think that we can leverage SDN from VM mobility and allocating resources, doing automation to service chaining and how you direct traffic in your virtual infrastructure. We can also leverage SDN to create those virtual networks and for multi-tenancy. So we think that SDN can be very, very key in enabling these things in a network. And perhaps NFV can become, that's my hope, a killer app for SDN. But that's my own perspective. Okay, so if you look at SDN, this is a very simplified version of SDN, simplified picture, trying to summarize and converse different perspectives on SDN. So if you try to bring those things together, you maybe get something like that, an SDN-based NFV where an SDN controller resides with your management orchestration system. You have the OpenStack Neutron also running there. And that's hopefully, so the key thing here is also have the APIs, the northbound interface, and how you can open this up to the network applications. And this may be something that we should think about standardizing, for instance. So when I want to plug an application that from a different vendor, I should be able to do that in a standardized fashion. The infrastructure today, it looks like there's it's a patchwork of different networks, although here you see like similar pictures of the network. In reality, you have a heterogeneity of networks in your infrastructure today. So the vision behind NFV is that as you move those physical appliances, your boxes, into VMs, right? All you need at the end of the day is connectivity amongst these VMs. That's all you need. Okay, so these VMs can reside anywhere in your network. They don't have to be co-located. They don't have to run on the same data server. Okay, they can be anywhere. And essentially, they can run on the cloud. And essentially, NFV removes all these boundaries and constraints in your network. It breaks down the barriers and opens up limited opportunities as it breaks down all these silos in your network. It's a value proposition for many, I think, in my mind, not just for the telcos. You can have application data centers. You can have applications in the enterprise. I call these, one of the key things, of course, is what I call the EVA principle, elasticity, velocity, and agility. Open source, again, is going to be very, very key. And I'll go over a few things what we do with Orange. Within Orange is a global telco with operations around the world. I'm out of the office here in San Francisco. We're very big. I don't need to go. So some of the interesting stuff that we're working with within Orange are on VPC, the Virtualized Evolved Packet Core, and VCDN. And here, as you see, we try to address two major trends. And this is mobility and video, right? Hence the proof of concept that we're working on. So the first one is a VPC. Virtualizing the VPC goes beyond virtualizing just a single function here. So you're trying to virtualize the entire architecture. And so you can virtualize the nodes that comprise essentially your EPC. The benefits, I don't need to go over these, are pretty clear: elasticity, agility, remote operations. You can run your EPC anywhere around the world. This is what I call also EPC in a briefcase. It's very portable, so you can move software, from one location, from one data center to another, so you can run it from anywhere you want. You can deploy it if you want next to your base station. And it's easy to integrate other functions such as IMS and deep packet inspection and caching. So what we've seen so far is like two approaches when it comes to visualizing the EPC. One is what I call the verticalized approach, where essentially people trying to map boxes, physical box today, into a VM into VMs actually that sit on a single blade server. We think that this is kind of inefficient because it still uses many processes and requires the encoding and decoding across the interfaces as you run these boxes on your server. As you see, there's a dedicated server per function, so it's kind of like inflexible. If you want to achieve high availability, which requires duplication, you have to duplicate the whole thing. So that's not quite efficient as we would like to. The other approach that we've seen from vendors is the approach where essentially you do a node disaggregation. So you run these functions that today run in a single box across your servers. So you have multiple VMs essentially making up those different functions. So that leads to more consolidation and leads to less complexity and essentially getting rid of the boundaries across between the different functional boxes. So we think that this achieves better service scalability. So if you want to have more policy enforcers, you can just launch a VM that does that, right? So because these applications are very interesting to us, and because if you have spikes in your network, right, and suddenly there's unforeseen traffic spike in one particular part of the network, what you'd like to do is launch a VM to handle these spikes. So that's why we think that this model is kind of appealing to us. And MVNOs, that's the, you can usually use this type of approach to create MVNOs in the network. So the other thing that we have working on today in our office here is the smart EPC, where you can actually embed, implement SDN type of solutions in your network. And this is a POC, essentially, where you can run, for instance, OpenFlow agents within that EPC architecture to do traffic offloading. And traffic offloading here, because everything is done in software, you can pick and choose what kind of criteria you want to use in order to redirect mobile traffic flows in your network. So that leads to better management of EPC. The critical thing about SDN, and if you're using OpenFlow, for instance, is that you can actually characterize flows coming into your network. So as you move, again, to just recap here, as you move things into software, you can see we have lots of possibilities. Right now, I can insert another software solution into my current software. So I don't have to go to the vendor and beg the vendor, so please add this particular capability and feature in your box, right? I can go do that with my software. So it's easy to plug in different solutions here. Okay, MVNOs, I'm going to skip that. The other thing is VCDN. This is another important use case we've been working on. The thing about content delivery is that it's a very volatile market. It changes a lot in terms of formats and protocols. So this is work done in France, actually, that really ahead in virtualizing the CDN. And here's also a picture of virtual cache nodes and also physical cache nodes. We're working with Akamai, Mellanox, and others to make this happen. And that brings me to what we see today happening in our world, which is what I call the softwareization of networking. Because the common denominator, after all, is software. So when you look at SDN and NFV, that's the common denominator, right? It's the power of software. So, and behind it, of course, is the programmability. We just need to pause for a minute and say, okay, what's going to be the impact on silicon innovation, right? Is that going to lag behind? So this is something to keep in mind. And also we have to be aware of hackers and bugs. And I'm not trying to get a stab on Google here, but this is something that happened like a couple of weeks ago when there was an outage in your Gmail. While Google can afford that, we as telcos cannot afford having an outage when it comes to critical services like 911, right? And I know that some of you will complain that your mobile coverage is often spotty, right? So, or you have dropped calls, but at least it doesn't happen for a few hours, hopefully. Okay, so these are some of the key takeaways. I have a few more stuff to cover here. So the one thing I want to point out here is that not all NFV use cases are, all NFV use cases are potential killer apps. So there's no single killer app in NFV. All of the use cases and killer apps can be different, can have different flavors for each operator. So we may think that, for instance, VPC and VCDN is for us, maybe something else for a different operator. Open infrastructure, again, it includes open source software and hardware. This is very, very important. We think that NFV can dramatically transform the service provider landscape. This is something that we see happening today, and how you can, it sort of transforms and changes the way we design, architect, and build and operate networks. So this is happening right now. Make sure you also go to conference receptions, because that's where you meet friends and new people. And I now want to completely switch things gears here and share some personal thoughts with you with respect to the future of the data center, okay? Or the future data center, if you like. So what we know is that data centers are growing very, very fast today. I think the average growth rate is about 15%, give or take, per year. So they double in almost 5 years. So Facebook spent about $210 million back in 2010, I believe, or 2011 for its Oregon data center. A lot of servers there. There's a huge TCO and upfront investment for building a data center, a very quite centralized architecture. Imagine if telcos had one central office per 100 million subscribers. That would be chaotic, of course. And we know that big data require bigger data centers. So the solution here obviously is to grow horizontally or vertically. That's like scaling up and down. But in my mind, this is not sustainable, right? We cannot keep building more and more data centers today. It's not sustainable. If you look like 10 years from now to 15 years from now, I don't think this is going to sustain, right? We had the mainframes. I think Jim mentioned mainframes. We had these like 30 years ago. They disappeared. So were the dinosaurs a little bit before that? So we just need to, provide some new ways of how we can essentially allow for information to be computed and stored around. So maybe we can go to a fully distributed model, move intelligence to the and processing and storage to the edge of the network, maybe close to your to the base station, for instance, or to some other edge device. The one fact that we know for sure is that the number of mobile devices this year will surpass the number of people on this world. Okay, so that means there's going to be a tremendous processing power in our hands. Okay, and maybe the cloud is us. I call this the Polarization of the data center, right? And this is a picture I took from the summit last week. Was someone from Next Computing building a data center out of a trash bin and using some solar power to power that. Now, who will prevail in this new paradigm? I don't know, but obviously it might be someone who owns the network. And when I say network here, it could be us, a service provider, that they own the infrastructure, but it could be also someone who's like a social network, right? And in fact, Facebook, they celebrate the 10th anniversary today. So what we need is sort of like an out of the data center thinking, right? We need to rethink how we can, build those distributed, if you like, data center models. Reality check, maybe come back in 10 years from now. This is not the right date. 2026 should be 2025, maybe 2030. Technology ages the same way as dogs, right? They don't really map to human years, so maybe it will take sooner than that, maybe a bit later than that. And just some final thoughts here. We are very, very embedded in virtualization. So virtualization is happening around us today. I take a personal plug there when we published the virtual output queuing paper back in the mid-90s. But you see also other forms of virtualization happening around us, whether it's Airbnb, VMs, of course, running on On servers, a zip car, you don't have to own a car, you can rent one. Time sharing for vacation, bicycle sharing, you don't have to own a bicycle, you just share one. Could be virtual currencies in the future, who knows? So what I know, though, is that virtualization, which is essentially sharing, is the new economy. With that, thank you so much.